Howdy, Dr. Alvarado. This is my final project presentation for ENTC 641. My name is Jonathan Sanchez. I am presenting the data analysis of a paper that Dr. Bhaskar and Dr. Patterson both referred to me. I have not started my thesis project yet, but this project is hopefully very similar to the kind of work I'll be doing. And it did give me a good insight on the type of things I'll be having to analyze when I start my thesis. Um, so the paper that I am looking into is actually called the Inert Gas Flow Speed Measurement and Laser Powder Bed Fusion Additive Manufacturing. The problem statements that I came up with based on this paper is one, does the speed reading contain any outliers? In the Excel given, there are three different speed quantities measured for each position. I wanted to go through and compare and make sure there were no outliers or anything that would set the data off and make it unusable. And then two, do any of the positions measured affect the flow speed measurement? So the speed measurement is very, very critical in this paper. It is what affects the amount of defects that result from this powder bed fusion print. So you don't want to go too fast because it'll create a bunch of different problems, but you also don't want to go too slow because that's what makes all these problems that they're stating pop up. You want to go fast enough to where those problems don't arise. So you kind of want to find a good medium. In order to do so, you really need to know what controls the speed, like what affects the speed. So it gives you three positions, the X, Y, Z position. I went through and did an ANOVA analysis of these positions, as well as to start off, I did an ANOVA analysis of the speeds that were given. We were given three different speeds. This is a small version of the chart. The rest of it is in the appendix. The ANOVA was done to make sure that the mean of all these three speed columns was can be considered equal. So that way there's no outliers, no problems in the analysis. After conducting that ANOVA, it was very, very clearly below the critical value, and the p-value was above the 0.05 alpha value, meaning that we failed to reject the null hypothesis, which is that the means are all equal. As you can see here, the averages all very similar, variances all very similar. This is a good set of speed data, so we were able to continue with it. From there, I show some charts of the different X versus the speed. So at the top here, we have the X values for each position. And then down below, we have the actual speed that goes with it. I did that for each chart on each position. For the X value, comparing it to the very first S1 speed column, the F value is way lower than the F critical. The P value is higher than the alpha, meaning that we failed to reject the null hypothesis, as in there is no connection between the X position and the S1 speed. The same can be shown for the second ANOVA of X versus speed 2, smaller F than the F critical, and as well for X versus speed 3. This shows that the X position value has no effect on the speed coming out of the nozzle. We continue with the Y position to check to see if that position has any effect on the speed. The results are the same as the X value. The Fs are way lower than the F criticals. That P value is way higher than the 0.05. Same thing for the second versus the speed 2, and the same thing for the speed 3. 0.424 versus 2245. That means that the Y as well as the X cannot be attributed to affecting the speed coming out of the nozzle. Lastly is the Z position. The Z position is actually different as those results come out. The F value is actually way higher, 24.2 versus the 1.9 critical. And the p-value is significantly smaller than the 0.05. The same happens for the next two novas, 24.28 versus 1.91. And then lastly, 23.98 versus 1.912. This shows that the Z position is actually what affects the speed of the nozzle as it comes out. So in order to change the speed of the nozzle, you need to change the Z position when printing, which is what was shown in the paper. And one of the reasons why, whenever they're making changes to the settings they want to print at, they change the Z value to adjust for it. But they wanted to go through and do the testing on everything to make sure that it all values. In the discussion, I go through and discuss all the results, basically how the for the first seven ANOVA tests that were done, the F is less, the F critical is less, is great. Sorry, the F found is less than the F critical, meaning that we fail to reject the null hypothesis. But then on the Z position, ANOVA is where we notice that it does come out larger than the F critical, meaning that we do reject the null hypothesis that it has no effect on it. In conclusion, the research paper that was used for this project is very elaborate and has a lot of information on the nozzle position and the gases used and all sorts of things. I took the data from that and with the guidance of Dr. Patterson, Dr. Baskar, went in and analyzed the first steps to make sure that the information that was given on those Excels is able to be analyzed properly and be used as good data, which hopefully will set me up for better thesis analysis once I can actually start my thesis in this winter, now that I have an idea of how I'm supposed to go about verifying all of these points and making sure that they do reflect what is meant to be reflected, basically. Thank you.